Hi, welcome to Virtual CB1A. This is Miss Rena. And for today's lesson in Mathematics, Science, and Technology, we're going to continue our discussion on measurements in science, operations in scientific notation. Specifically, we are going to focus on addition and subtraction. Let's read the learning objectives. At the end of this lesson, you were expected to understand the rules in performing operations, addition, and subtraction in scientific notation. And of course, perform those operations in scientific notation. Please recall that a number is in scientific notation if it is in the form a times 10 raised to n. In performing addition or subtraction, make sure that the exponents for both given numbers are the same. If the exponents are the same, proceed with the operation. Add the numbers a and affix times 10 raised to the power of n. Look at this example. Add 3.7 times 10 raised to the power of 3 and 4.1 times 10 raised to the power of 3. Both has the exponent 3. So all we have to do is to add the numerical coefficients a. We have 3.7 plus 4.1, which is equal to 7.8. Now let's affix times 10 raised to the power of 3. That is 7.8 times 10 raised to the power of 3. That is the final answer. It's really easy, right? Let's have another example. Add 3.7 times 10 raised to the power of 3 and 8.5 times 10 raised to the power of 3. Again, they have the same exponents, 3. So all we have to do is to add a's. We have 3.7 plus 8.5. We will arrive with 12.2. Now let's affix times 10 raised to the power of 3. You will end up with 12.2 times 10 raised to the power of 3. But take notice at the new value for a. That is 12.2. According to our rule in scientific notation, your a should be between 1 and 10. But 12.2 is greater than 10. So what are we going to do next? So if the new coefficient a exceeds 10, move the decimal point until a is greater than or equal to 1 but less than 10. It should be between 1 and 10. Add the number of times you move the decimal point to the left to the exponent. If the movements are to the right, perform subtraction. So let's take here 12.2 times 10 raised to the power of 3. In order for us to arrive with a value that is between 1 and 10, we have to move this decimal point 1 unit to the left. So since we move to the left, we are going to add 1 to our exponent. So our new value is 1.22 times 10 raised to the power of 4. Okay? I hope that was clear. Let's have another example. Okay, this is for subtraction. We are going to follow the same rule. If you have the same exponents, just perform subtraction on the values for a. We have 9.9 and 4.1. So 9.9 minus 4.1 times 10 raised to the power of negative 4. That is 5.8 times 10 raised to the power of negative 4. Okay? Let's look at another example. We have 4.1 times 10 raised to the power of 4 minus 3.9 times 10 raised to the power of 4. Again, we have the same exponents for 10. What we're going to do is to perform subtraction with the values of a. We have 4.1 minus 3.9, and of course, affix times 10 raised to the power of 4. You will end up with 0.2 times 10 raised to the power of 4. But look at the new value of a. The a that we have here is less than 1. By definition, a number is in scientific notation if it is in the form a times 10 raised to the power of n such that a is between 1 and 10. So we have to make adjustments for this to be greater than 1 but less than 10. So move the decimal point 1 unit to the right and subtract 1 from the exponent. So from our value here, 0.2 times 10 raised to the power of 4, we have to move 1 unit to the right. This is the new decimal point. And then subtract 1 on the numerical coefficient, on the exponent, which will give us 2 times 10 raised to the power of 3. Okay? I hope that was clear because we are going to move forward to the more complicated one. If the exponents are not the same, look for the number with the lower exponent. Make necessary decimal point adjustments to the number with lower exponent to make the exponents the same. Perform the indicated operation to the numbers a and affix times 10 raised to the power of n. This is our example. Add 2.26 times 10 raised to the power of 3 and 3.7 times 10 raised to the power of 4. Which among these two has the lower exponent? So 2.26 times 10 raised to the power of 3 has the lower exponent. So let's adjust 2.26 times 10 raised to the power of 3. If we move 1 decimal place to the left and add 1 to the exponent, you will end up with 0.226 times 10 raised to the power of 4, giving us two numbers that has equal exponents. Even though this one is not in scientific notation because a is less than 1. We're going to make adjustments later if there will be a need for adjustments. So let's proceed with the operation addition using our new number here, 0.226 times 10 raised to the power of 4. So add them up, 0.226 plus 3.7, since they already have the same exponent, so affix times 10 raised to the power of 4. It'll give you 3.926 times 10 raised to the power of 4. Since this is already in standard scientific notation, there is no need to make any adjustments. Let's go to the next slide. This is our new problem. 1.02 times 10 raised to the power of 7 minus 3.9 times 10 raised to the power of 5. Which among these two has the lower exponent? So 3.9 times 10 raised to the power of 5 has lower exponent. So we have to make adjustments. Let's adjust this to make the exponents equal. Both of them should have the exponent 7. So how many movements do we need for it to be 7? So we have to add 2 to the exponent. Therefore, we have to move 2 units to the left. So this new number will be 0.039 times 10 raised to the power of 7. Since they already have the same exponent, perform subtraction. We have 1.02 minus 0.039 and of course, affix 10 raised to the power of 7. We're going to end up with 0.981 times 10 raised to the power of 7. But this a here violates our rule for standard scientific notation because the number here is not between 1 and 10. So let's make some adjustments. For it to be between 1 and 10, we have to move the decimal place 1 unit to the right. If we do that, then we have to subtract 1 from the exponent, giving us 9.81 times 10 raised to the power of 6. Okay? Alright, I hope that was clear. Let's do another one. This is our number. 1.099 times 10 raised to the power of 2 minus 9.85. Is it possible to to apply subtraction? Yes, it is possible. How? We have to transform 9.85 into standard scientific notation. How do we do that? Do you remember laws of exponent? If we have x raised to the power of 0, that will equate 1. So all we have to do is to write it in standard notation, standard scientific notation, having the exponent 0. Because 10 raised to 0 is just 1, and 9.85 times 1 is equal to 9.85. Okay? So since na-adjust na natin siya, we have to make another adjustment so that both of them will have the exponent 2. How are we going to do that? So we have to add 2 to the exponent here. If we add 2 to the exponent here, then we have to move 2 decimal places to the left. Therefore, our new number is 0.0985 times 10 raised to the power of 2. Perform subtraction. 1.099 minus 0.0985 times 10 raised to the power of 2 is 1.0005 times 10 raised to the power of 2. Tapos na. Thank you. So this is the end of our lecture for today. Thank you for listening and see you next time. Bye!